First example, exercise 5G, question 1. Typical one where most students get stuck because they're sort of like, when it comes to logs and exponentials, there's only the same amount of techniques, but if you don't practice it enough, a lot of you will look at this and go, how do I do it? So I'll show you what most students would do when they see a problem like this, okay? And then you tell me what's an alternative way to solve for k. That's what you're trying to find. So let's have a look. I got 1a. You got log 2 of 8 is equal to k times log 2 of 7 plus 2. Naturally, what most students would do is try to get k by itself, so subtract 2 on both sides. You get log 2 of 8 minus 2 equals to log 2 of 7 times k, and then divide both sides by log 2 of 7. So you get k is equal to log 2 of 8 minus 2 all over log 2 of 7. Cool? Okay, now the problem is, like, even if you split that fraction up, you can't simplify it. There has to be a better way to simplify this. Okay, I mean, the answer is still correct. If you type that in your calculator, you still get it correct. But we want to find a better approach, something that you can collect the logs together, because right now you got 2 of these logs sitting here, which we don't like. So, what's the alternative approach? Can anyone think? Same things I taught in the past. That's the first thing. Every time you got some number multiplied to the log, do that. Okay? That's what they always do in the exams. They will give you something like this, and they want you to use that law number 3. And I kept saying to you guys, most students will remember law 1 and 2, but they'll forget law number 3. Bring the k up. That's law number 3. Yeah, so law number 3, we're now going to take the different approach. Instead of moving the 2 first, we are now going to change it to log 2 of 8 is equal to log 2 of 7 to the power of k plus 2. Now, what do you think you're going to do next? Why do we use law 3 first? There's a key thing why we do this first. Anyone know? Bam. What are you going to do next? Luke, what would you do?
2 to the power, inverse to the power, inverse cancel the logs, 2 to the power.
Yes, you would, but the problem is on the right-hand side, you've got 2 terms. You've got the log and you got the 2. So if you do 2 to the power of, you get this entire thing, so it doesn't cancel out. So, something before that. You have to do something before you do the inverse, which you will eventually do, but not yet. What do you do? Luke?
You could turn the 2 into a log 2, base 2.
Which one? Log 2 of 8?
So, you could turn the 2 into log 2 brackets 1.
Oh, yes, you could. Actually, that method would work too. It's just a bit longer. I want to find something more obvious at this point. Because remember, the goal is to simplify the logs. I don't want 2 logs. And there's one small thing right here that we can do. And examiners always do this. Yeah. That's as simple as it is. What I would do here is I'd say subtract both sides by log 2 of 7 to the k. And I would say on this side, same side, subtract log 2 of 7 to the k. These 2 will cancel out. What you end up with now is you got log 2 of 8 minus log 2 of 7 to the k, which is equal to 2. Why did we want to do that? So it's log 3, then log 2. Law number 3, then law number 2. See, we got the subtraction, law number 2. Okay, but just like your exam questions, the one I gave previously, you always want to do number 3 first before you can do number 2. The reason why you want to do number 2 is because you reduce the log 2's to 1. That's simplifying. You're simplifying the problem. So now it becomes, using law number 2, we can say this is log 2 of 8 divided by 7 to the k. Okay, equals 2. Now you can do what Luke said before. So now you got, on the left-hand side, you got a base log, and you got equals 2. They're 1 term each. So now you can say the inverse of log base 2, you can say that's exponential base 2. So here we go. I'm going to do exponential base 2. I'll do 2 to the power of log base 2 of 8 over 7k is equal to 2 to the power of 2. And this is nice because if I did exponential base 2 to the power of all this, these two are inverses, they'll cancel out. But if you had two terms, you can't just cancel it out. Okay, if you have two terms there, you can't do that. But because it's log of all this, these two are inverses. So you can remove that. This one, you know, 2 squared is 4, and then you end up with 8. So this cancels out. You end up with 8 over 7 to the power of k equals to 4. Yeah, now you can cross multiply. Remember fractions, you don't like fractions. It's divide by 7 to the power of k times those sides by 7 to the power of k. So here we go. I'm going to times both sides by 7 to the power of k. That cancels out, and we've got 8 is equal to 4 times 7 to the power of k. Divide both sides by 4, so now I've got 7 to the power of k is equal to 2. And this is nicer. You see the problem, I've reduced it much more in comparison to the first approach. Okay. And that one I couldn't simplify the logs, but this is nice, because now I can remove the 7 by, how do I remove the 7? 7 to the power of k. I want to remove the 7. I want to find k. What do I do? What's the inverse of an exponential? Log. And this is a base 7, so it'd be log 7. Okay, so here we go. At this step here, I would say both sides log of base 7 of 7 to the power of k, log base 7 of 2. And we know that log 7 of base 7 will cancel out, so you get k is equal to log 7 of 2. And this is a much nicer answer than the one you had up here. See that? Okay, so it was just in a small thing. There's only 2 rules there that you're really using. It was do number 3. Anytime you get a k value or something times a log, use number 3. That's what they always do at the end of the exam. Use number 3, and it's likely you either use 1 or 2 to simplify the logs. So you can remove that and come down to that one. That's a nice answer. Okay. So that means you can do the next 2 after that. How do we feel with that? Does that make sense? So inverse of log is exponential. Inverse of exponential is log. Just like times and divide, add and subtract, square and square roots, right? They all follow the same techniques. Okay. All right. Now there is one small thing. What happens if I give you something like this? Let's say 0.3 to the power of x equals 2. Okay, I'm just making it up, by the way. If I want to find x, how do I find x here? What do I do? It's a simple process. Exactly the same thing, but there's only one small thing you have to pay attention to. How do I find x? What's the technique? Luke?
Log base 0.3 both sides, and then both log x with fraction, and then so log 0.3. So I guess like 0.3 cancel out to 1.
Oh, no, you were, oh yeah, you're correct. Yeah. Yeah, excellent. So just like before, we had 7 to the k over here, and I asked you, how do you remove the 7? It's an exponential. You told me inverse of exponential is log, so we did log base 7, both sides, yeah? Same thing over here, if you got base 0.3, see the base is 0.3, that's an exponential base 0.3, and to remove it, it's the same thing, logarithmic base 0.3. Now if I do logarithmic base 0.3 on both sides, base 0.3 of 0.3 to the power of x is equal to log base 0.3 of 2, see I'm just doing it to both sides, I'm keeping it balanced. Time is like times, divide, add, subtract, multiply, divide, yeah? Actually, I said that twice now. Anyways, and so from here, same thing, log 0.3 of 0.3 will cancel out, and we know that it will equal to x, okay? Because those are your inverses there, and then you got log 0.3 of 2, whatever that is. I don't know what the answer is, but I do know one thing. What do you have to pay attention to? What do we know already about log with a base 0.3? It's one thing you're going to know. And that's a property that they normally use for exams, for multiple choice questions. What do you have to be careful of? Yes? What's the difference if I had log 7, log base 7 of 2, and log 0.3 of 2. What's 0.3 do? See, if you can't figure it for log, then think of exponential. If I had exponential 0.3 as a base, how is 0.3 different to 7? What does 0.3 mean? Yes, Naz?
If you like square it or something.
You're on the right idea, but no. Leah?
Well, I suppose the same thing. If you have like a number that's less than 0 and you raise it to a power, it won't get bigger and get exponential.
No, that's good. Is that what you said?
Yeah, it's what he said.
Oh, sorry, I didn't hear that.
He said.
I thought you said it gets squared. That's why I was like, oh, it's right, but not right. It's exactly what you said. So when we say 7, or like 2 to the power of something, right? What you're actually saying is doubling it. That's what you mean. It says for every x value, keep doubling it. Like 2 times 2 times 2 times 2 just means double, 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 double. If you have base 3, then you mean triple, 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 triple. If you have half, 2.5, it means half, half, half. You keep halving it, so it gets smaller. Then 0.3 just basically means you're thirding it. You're making a third over time. So if I had 10, divide that by 3. Whatever that is, 10 on 3, divide that by 3. Divided by 3, divided by 3. So your graph, 0.3 to the power of x, actually is an exponential graph, but what we call a decay. It's a decreasing function. Yeah? Whereas this is 0.3 to the power of x, whereas if you had 3 to the power of x, it'd be the other way around. So how does this affect your log? See, if your log is normally this way, then how does the 0.3 change the graph? What does the graph look like now? So I draw, this is what your log base 3 of x will look like. Then what will, and I'll do in red, if this is exponential for 0.3 of x, then what does log base 0.3 look like?
Would it be a reflection of that in the x-axis? What?
Not in the x-axis.
What?
What would it look like? It is a reflection in the line y equals x, but I'm interested in what it looks like. What will it look like? Oh, is that what you mean by reflection in the x-axis?
Yeah.
For a log graph?
Yeah.
Yes, you're right. Yes, yeah. Yeah, you're right.
What are we doing?
All right. If I asked you to draw, all right, I'm gonna rub off the blue. Okay. If I asked you now to find the inverse function or draw the inverse function of this, what would it look like? What was the technique I taught you?
Wouldn't it be like basically like that twisted 90 degrees?
Tilt your head. Like if you ever find it difficult to draw the inverse, tilt your head. So this is the axis. Now just copy whatever you see on the right hand side, copy it on the left. It'll be exactly the same. So tilt your head and then draw. So if I tilt my head now, and I'm going to do it in purple or green. I'll do it in green. So I'll tilt my head. I just got to make sure they're both symmetrical. Yeah? So I'm drawing it so that whatever's on that right-hand side, see how I'm just tilting my head? I'm like, all right, well, it feels like that. For this part, I just have to draw it out. So if I draw it out now, this is what Luke was saying. It's like a reflection in the x-axis. So it goes down, it goes closer to that. Comes out. Can you see how I'm drawing it? You tilt your head is symmetrical. Okay? So this implies when you say 0.3 of x equals 2, what you have to realize is that value there, what's the x-axis intercept? Which is the y-axis intercept. What's the y-axis intercept from 0.3? 1. See, when x is 0, y is 1. So this is what I mean by looking at the properties here. We know that this is 0, 1, then this has to be 1, 0. So when you say log 0.3 of 2, 2 has to be over here. Because that's where 1 is. If this is where 1 is, when x is 1, then at x equals 2, what's my y value? We don't know the y value, but we know one thing. What about it? It's negative. So when we say log base 0.3 of 2, the first thing you have to know is it's negative. Now that's important because when you do inequalities, remember every time you divide or times an inequality by a negative, it switches the signs. Yeah? So when you're doing in your exams or your SATs, it's likely that they'll give you a graph like this and they do 0.3. You just have to know that log base 0.3 is going to give you a negative if the number is bigger than 1. Okay, when it's bigger than 1, you know it has to be a negative value. That's the only thing you're going to pay attention to. Okay? So if you have a look at your textbook, they do try to describe it in your textbook as well. So where's your textbook? Here we go. If I go up a bit, they try to tell you here, they did 0.3 to the power of x equals 5. Solve for x. This value here is no longer positive. This is actually a negative. Okay, and that's why they try to tell you here that it's strictly increasing normally, but when you change it, it now becomes strictly decreasing because that's what's happening with the y values. Okay, and that's what I mean. The better you know your exponentials, the better you know the inverses. So if you don't know what log of 0.3 of x is, then just think about it as 0.3 to the power of x, and you can picture that. It's easier to picture exponentials because you've been training on that. Logarithmic is harder. So if you always think about the exponential, you know the properties for log. Yeah? All right. So it only matters when you start doing questions like number 3. So it's likely that when you're doing this one, okay, when you're doing this on your calculator, you just got to know the log base 0.2 on both sides. It's going to change that sign because it's negative. Okay, because when you're doing the log of each side, you divide them. If you're dividing by negative, that sign will change. Okay, so I'll do this example, 3e. I'll do 3e just so you can see. We'll do 3e together. So here we go. Where's my... Where's 3? 3e. All right, here we go. 3e. Now, same thing, 3e. 0.2 to the power of x less than or equal to 0.4. If you want to find x, same thing. If it's 0.2 as your base, to remove the 0.2 as your base, you would logarithmic base 0.2. So that's what I'm going to do. Logarithmic base 0.2 of 0.2 to the power of x is less than or equal to log base 0.2 of 0.4. You can use law number 3, bring the x down, or you can say that they both cancel out. So x here, or technically, if you actually show the techniques, you can see what you're doing here. That's x times log 0.2 of 0.2, less than or equal to 0.2, 0.4. Okay? Is it 0.4? Yes, it is. Okay? Now what we can see is x, and these will cancel out to be 1, so x, now we've got less than 0.2 of 0.4. Now in this case, the sign doesn't change, and it's because you're not dividing or timesing by a -1. But log 0.2 of 0.4, is that a positive value or is it a negative value? And how do you know? Because I know you can use your CAS and you'll be fine, but I'm just more interested in observing the values.
Because 0.4 is less than 1.
Fantastic. Because, you know, if you change that question, log 0.2 of x, right? If you just imagine this graph, y equals to log 0.2 of x. Okay? If you can't picture what that graph looks like, then what you can do is change that to an exponential. This is the same thing as saying 0.2 to the power of x. Analyze that graph. Now 0.2 to the power of x will look like this. Decreases, but the y-intercept is still 0, 1. So if you draw the inverse function to this, which I'll do it in red, it's still 1, 0. So if you do 1, 0 there, and you ask yourself, Where's 0.4? 0.4 is somewhere over here. It's obviously positive. Y values are positive. So this one is positive. Okay? But that's what I mean. Paying attention to the bases, paying attention to the value. If it's log 0.2 of 1, we knew that was 0. But then what's log 0.2 of 0.4? Okay, and you can picture the graph, or you can think it as the exponential. Okay, but that's the only thing you got to pay attention to when you're doing those kind of questions. That's it. Okay, whereas this one would have been negative. What? So because if you did log base 0.2 of 3, 3 is larger than 1. 3 is over here, so the y value would be negative. Okay. What? You confused, Jeff? What does that make sense?
So I look at that number in the bracket, and that number, take a look at it on the graph, and it's positive.
Yeah. The only time you got to be careful of is, we just know that as long as this is equal to 1, we get 0. So sometimes there's a translation that you just got to make sure this domain equals to 1 will give you 0. In our case, we already know that's the x-intercept, and because we said 0.4, 0.4 is over here. So log of that 0.4 will give you that.
Does it mean the graph is positive? Or like,
The graph is a negative, it's like a decreasing function. But when x is 0.4, what is the y value? Is what we're asking. Does that make sense?
oh, so we just try to double check.
Yeah. So in this case here, I can determine that this value is positive, and just being careful. That's all. Okay. Okay. But that's pretty much exercise 5G. Inverses. Just want you to revise that idea that whatever the base is, you can do the inverse of that base by using log. Okay, that's all you're doing. Base and then inverses, the same things. Okay. I'll leave it there, and then you guys can revise for your SAC coming.